Okay, so first of all, I want you to take this rational function. Does anyone know why it's called a rational function? Okay, let's backtrack. What is a rational number? Yeah. Well, yes. I'm sorry. You were so right. Yes. You can't take. It's a perfect square. But why is it a perfect? Like what makes the perfect square a rational number versus like the square root of 2? Whole numbers are like 1, 2, 3, 4, 5. There's a bad number? Yeah. There's no such thing as a bad number. Yes. So, if I said, you guys remember like integers, whole numbers, irrational numbers? What's the definition of an irrational number? No, that's an imaginary number, has the I. Never comes to an end. So if it's a decimal, never simplifies, never surrounds, never does whatever, it's called an irrational number because you cannot rewrite it as a fraction. So today we're going to deal with rational expressions, I should say, rational expressions, which means they're going to be expressions that are written as a fraction. You had these in Algebra 2, where I would take this and I would ask you to combine it into one fraction with one denominator. In order to do that, what do you have to first find? You have to find a common denominator and then put both of them over that common denominator and then add, right? Okay, I'm going to give you a minute to do that. Now, so we decide our lowest common denominator is x minus 3, x plus 2. So this first fraction, I'm technically multiplying by x plus 2 over x plus 2. So I'm going to be left with 2 times that, so it's 2x plus 4. Everyone good? Plus the second fraction, I'm going to multiply by x minus 3 over x minus 3. Because technically I'm multiplying by 1 and not changing it. I'm distributing this negative 1, so I'm going to have negative x plus 3. When I combine my like terms, I'm going to have x plus 7 over x minus 3, x plus 2. So you learned how to do that already. What we're going to do today is we're going to start with this, and we're going to backtrack it to that. It's called partial fraction decomposition. And it comes in very, very handy when we're doing calculus and we go to take a derivative. It makes our lives so much easier. So, yeah, derivatives. Don't worry about that. We'll worry about that later. So we're going to recognize partial fraction decompositions of rational expressions, and then we're going to find them. So this is the work that we just did. This was x plus 7. We are going to be given this, and we're going to split it into those two parts. Okay? So it's a lot worse than it looks, but so there's steps. So we have, first thing we're going to do is we're going to look at our fraction and we're going to decide whether it's a proper rational fraction or not. So in third grade, if I had 8 over 3, we said that was an improper fraction. Why did we say that was an improper fraction? Because the numerator is larger than the denominator, then we simplified it into the next number. And technically what we did is we took 3 and we divided it into 8. Yes? Okay. Now what we're going to do here is if I have rational expressions, I'm going to have something like x to the 4th with all this other stuff. And if I'm dividing it by x squared with all this other stuff, the degree of my numerator is going to be 4. The degree of my denominator is going to be 2. That means I can simplify it by doing long division and dividing the numerator by the denominator, just like we did in third grade. It's a lot more work. Yes? So the first thing I'm going to do is I'm going to check to make sure we want the degree of the numerator to be less than the degree of the denominator. And it has to be less, not equal to, it has to be less. That's the first thing we're going to do. After we do that, we're going to factor the denominator completely, and then we're going to have 3 things that happen. We're going to have either linear factors. If I say linear, what does that mean? Straight. Well, it's a graph of a straight line. So what's the degree of a linear, Annie? Yeah, so it's like x, so the degree would be 1. So if my factors all have just an x in here, they are linear factors. So then what I'm going to put up here are just going to be constants, because what's the degree of a constant, Lauren? Huh? Nope. The degree of if I have x, like if I have x plus 3, that has a degree of 1. If I just have 4, what's the degree of that? 0. So that has a degree of 0. And then, so I can have linear factors. I can have quadratic factors. If I have a quadratic factor, what's the degree of the quadratic factors? Francesca. Quadratic equation, what's the degree? 2. So these would have a degree of 2. So if I notice now, when I look at my numerator, it's going to be a linear term. It's going to have a degree of 1. Does that make sense? So here, this was a degree of 1. We were picking our numbers with a degree of 0. If my factors have a degree of 2, then I'm making my numerator with a degree of 1. Okay? Are you with? We will not do anything larger. We will not have a factor to the third power because we'd all just want to cry. Well, not in here. I'm never going to say never.
Oh, not here.
Not in here. So what we're going to first do is we're going to do a distinct linear factor. So what I'm going to do is I have this which is combined with one denominator. I'm going to ask myself, what is the degree of the numerator? And we say 0. And what is the degree of the denominator? 2. So that is less than that, so I'm good to go. I don't have to divide. Correct?
Yeah.
Now what I'm going to do is I'm going to look at the denominator. I'm going to factor it. Josie, how do you factor it? How do you factor x squared minus 1? What did you say? X minus 1, x plus 1. Doesn't matter the order that I write those in. No. So those are my factors. What kind of factors are they? What degree are they, and what kind of factors are they? Abby? What's the degree of each factor? 1. So what do they call? Yeah, so they're both linear factors. Everyone good? So I'm going to take this fraction. I'm going to set it equal to. I'm going to put an a over here over one of my factors, x minus 1. I'm going to put a b over here, x minus plus 1. Everyone good?
Are A and B like variables?
They're variables for now. I have to get numbers up there. The numbers that make it work, like correct numbers.
How do we know it's addition?
Because if it wasn't addition, then when I solve for b, it ended up being a negative number.
Always.
It's always addition, and if I want to subtract, b will end up being a negative number.
Okay.
Okay? Then I have a negative sign in front of it. Whoa. All right, so what I'm going to do is I'm going to pretend like I don't have this, and I'm looking just at this, and I'm going to try and condense it back to a denominator, one denominator, right? So I know my lowest common denominator is that x minus 1, x plus 1. Everyone with me? So in order to do this, in order to bring this a down here with this common denominator, I would have to multiply this by x plus 1, yes? Which means I'm going to have to multiply my numerator by x plus 1. So I'm going to have a times x plus 1. Yeah? And then here, I would have to multiply x plus 1 by x minus 1. So here I'm going to have this plus sign, then I'm popping down, and then b times x minus 1. Okay? And that's equal to this fraction that I originally started off with, which is 1 over x plus 1, x minus 1. Since these denominators match, do I need them to find a and b? No. So I'm going to ignore them for a second. I'm going to have 1 is equal to, there's two methods to solve it. I'm going to just start off like this. We'll go slow. Want me to go slow? Yes. So there's two ways that you can solve this. If I have linear factors like this, I'm probably going to do the substitution way. So that's the way I'm going to show you first, and then I'll show you the system's way second. Because substitution way doesn't work all the time, unfortunately. So if I look here and I ask myself, what would make this factor equal to 0? And what would you tell me? If x was equal to what would make that factor 0? -1. So I'm going to say, let's suppose x is equal to -1. So any place I see an x, I'm going to substitute -1. If I had x's over here on the left side, I would make them -1, but I don't have it. So I'm going to make this 1 is equal to a times -1 plus 1 plus b times -1 minus 1. The reason why I did that is because this is going to be 0, which wipes out that a. Are you with me? So I'm going to have 1 is equal to -2b, which means b is equal to -1/2. So that's what happens when I set this factor equal to 0. Now I'm going to ask myself, what happens when I set this factor equal to 0? So what would x have to equal here to make this factor equal to 0? 1. So let's say x is equal to 1. Again, if I had an x on this side, I'd have to substitute it in. I don't. So I'm going to have 1 is equal to a times 1 plus 1 plus b times 1 minus 1. There's 1 is equal to 2a. This is equal to 0, yes? So a is equal to 1/2. Yeah.
You're always just picking numbers that can't solve them.
So I'm going to put those back into my original equation, like that I started up here with. So my a was over the x minus 1. So I'm going to have 1/2 over x, what did I just say? Minus 1 plus, oh, actually it's minus 1/2 over x plus 1. You know I can't read it like that, right? Something like that. What? Why not? Yes. Dylan, what am I going to do? We're in math class, focusing on the problem.
What?
What?
Oh, no, it's not.
I don't want to have a fraction in a fraction. I don't want to have the complex fraction.
You would.
Remember the appendix that we just did. There's 2 ways I can do it.
Couldn't you?
Multiply what by 2?
You're not. No.
You just want to get rid of the 1/2?
But, oh. Whatever you do, the top of the bottom.
Yeah, so I can multiply this by 2 over 2. And
Yes.
so I would do the whole thing, yes?
Yeah.
So that would be at 1 over 2 times x minus 1 minus 1 over 2 times x plus 1. That's one way I could have done. What's another way I could have simplified it?
You like switch with it. Get X
No, because if I would have keep switching off, whatever did I say? Why can I not say that right? I would have had 1/2 times, and then you're going to flip this 1 over x minus 1. So I'd still end up with 1 times 2 times x minus 1. Because
Well,
this
you
is
can
under,
do that.
you can do that, yeah, but you said that wrong. You know what I mean? But that's great, but that's not what I'm looking for. I'm looking for what else I could have done. Remember the appendix as well as I did. Remembering that I could factor something out. What could I possibly factor out? A 1/2 here. At this step here, I could have factored out a 1/2 from the whole thing and made this 1 over x minus 1 minus 1 over x plus 1. either one of these, either this answer or this answer are okay. Either one of those is fine. Good? Huh?
You switch with the time.
Well, no, that's fine, because you're gonna do it for both, because you're gonna end up right here. This is what you're gonna end up with. We're just doing it a different way. Okay, remember how I said there were two ways to do it? And I said that was method one? Now I'm gonna show you method two, and I can do something pretty slick that you guys can't do.
Question.
Okay, I'm listening.
Where did the negative 1/2 go?
What negative one?
When you
She's
solve,
changed into a subtraction problem.
I changed it to subtraction. Here's the 1/2. So B was -1, right? Negative
Yeah.
1/2.
Yeah.
So I could have put plus a negative 1/2,
oh, okay.
but I chose not to, and I made this a minus sign. Okay, now I do believe this is the second one. Yes, it is. So I'm going to pretend like I'm going to clear everything before this. So when I do the substitution way, because sometimes the elimination way will not work. I'm sorry, the substitution way will not work, and you have to do the system way.
Which way do you like more?
I have no favorites. I would have no preference, huh?
So you always do substitution or just?
We just did substitution. You'll recognize the system when we do it, ready? So the system says I leave this here, I multiply the A, I multiply the B. Then I say to myself, well, over here I have terms with X. So I have this with an X, and I have this with an X. But when I look over here, do I have anything with an X?
No.
No. So it's understood to be? If you have nothing in math, what's it understood to be? 0. So 0 is equal to A plus B. Because I think of this as 0x plus 1.
Wait, does that mean GX minus B?
Okay.
Yeah.
Oh, yes. So 0x, I have no x over here, so I can think of it as 0x. Everything with all the coefficients of x, I'm going to write them as one system, one equation in my system. Okay? Then the second equation is going to be the constants. So in here I have a constant of 1, and then this has a constant and this has a constant because it doesn't have a variable, right? So I'm going to have A minus B. Now I have two unknowns and two equations. That would be a system. And I could solve that system fairly easy, could I not? So I'm going to have 2A is equal to 1, A is equal to 1/2. And then put that back into either one. Let's say I put it back into this one. 0 is equal to 1/2 plus B. B is equal to negative 1/2. And then that's going to be the same work from that point on to the rest of it. Yes, sir?
I just have a question. So you just pick both of these X's.
Yes.
You can just do that.
Yes. Let me make one a little bit harder, shall we? So we did. Why do I have that question?
Yeah.
All right.
How would you cancel for B though, or for A?
Huh?
How would you cancel for A if you get B?
Once I have A, I substituted in 0 is equal to A plus B. I substituted that A in for, I substituted the 1/2 in for A to find B. All right, so this one, we did that one. This one, this is what's called a repeat linear factor. So what that means is technically I see this x squared, and I might be so tempted to think of it as a quadratic factor because it's raised to the second power. But it's not, because I can think of x squared as x times x plus 1. So this is what's called a repeat factor because it occurs 2 times. You with me? So when I go over here to write it, I'm going to start off as a over x. This is a trick. Now I'm going to do b over x squared plus c over x plus 1. So this is the reason why I have to do it. If I just wrote a over x plus b over x plus c over x plus 1, if I just wrote it like that, and I said, okay, here's the problem, what's your lowest common denominator? If you're just looking at x, and x plus 1, what do you say your lowest common denominator is? X times x plus 1, and that's not what my denominator is. That's why I have to make sure that one of my factors has that repeated together, so that when I find my lowest common denominator, I take into account that that's been repeated. Are you with me? Okay, I'm pausing. Ooh, I'm so glad you said that. The degree of my numerator is what? 2. But if I were to distribute this, times this, I would have x cubed plus x. What's the degree of my denominator? It's 3, so I don't have to divide.
I was thinking.
Yes.
Okay. I thought the top had to be larger than the bottom.
No, the top has to be smaller than the bottom. Why did I say top and bottom? Numerator has to be. What? Are we good?
Yep.
Okay, so those are my factors, yes, so I am going to write, like I'm going to ignore the denominator from now on. Are you good with that? The denominator, like I'm not going to write all these over x squared times x plus 1. But I am going to ask myself, what do I have to multiply this x by to get x squared times x plus 1? And you tell me x plus 1.
Why is it?
Because I already had, this is the x that I have there, this is what I need. Yes? So, I'm going to write neatly. I'm not going to write messy. I'm going to write equals ax times x plus 1. Everyone good with that? Do you understand what? This?
Yeah, I don't think they're ABC.
Why are you getting the ABC?
Why?
Or x
Why?
squared,
Why?
2x
Because you're
squared.
trying to find the constant, but.
Yes, I'm trying to find the numbers. That's this here. This is my A, my B. I don't want to do subscripts. You want to do subscripts? No, I don't want to do subscripts.
I'm just like, why?
Because you need this, you need something in the place to solve for.
I don't get the denominator. I don't know how we got that.
How we got that?
No, I don't know how we got A over, I don't know how we got the denominator. How did we do X?
So your factors, so like back here, my factors were, oh, go back one more. My factors were x plus 1, x minus 1. So I had an A over one of those factors and a B over the other one.
Yeah.
Yeah? So this one, when you have a repeat, because technically I have this is like, this x squared is really x times x times x plus 1. So one of my denominators is that x. One of those denominators has to be that x squared to show that that x is repeated. And then the last one is the x plus 1.
Wait, are you always putting like A and B over that? Like, you always choose your variables over the factors?
Yes. And then I'm always probably going to start with A, B, and C.
Yeah.
And D, E, F,
So like
G.
whenever you just split the problem.
Yes. Okay?
Sure.
How many overcomes are we?
Because if we did that, it's x times x squared, which is x cubed times x plus 1.
No. If you look at this and I said, what is your lowest common denominator? What would you tell me?
X times x plus 1.
No, I would tell you x squared times x plus 1.
Yeah, I don't know how to find this.
You don't know how to factor?
Well, I guess I
factor?
can.
Where do you get the third, like, fourth?
Huh?
You got the x squared, which I understand that. You got the x plus 1. Where'd you get the x?
Because x squared is technically x times x. So there's the x. The factor is x. This x squared tells me that it repeats.
So why didn't you see x plus x?
Like, so,
look at here and I ask you what your lowest common denominator is, you would tell me x squared times x plus 1, which is what I have. If I didn't have this term and I just had the x and the x plus 1 and I asked you what your lowest common denominator was, you would tell me x times x plus 1. I have to have this one squared so I know that originally it was squared. To show that the factor is x. And the x squared is to show that it's repeated. Let's do this one and see. It may make sense as we go. It may not. We'll find out. So when I go to do x squared and I want to have the common denominator of x squared times x plus 1, do we all agree that I'm just going to multiply this by x plus 1?
Yes.
And this by x plus 1, yes? So down here I'm going to have plus b times x plus 1.
These are just the numerators.
Yes. Because the denominators are going to be x squared times x plus 1. And now what am I going to multiply c by? X squared. So this will be plus cx squared. Now, if I try and do the substitution, and I put in x is equal to 0, that's going to eliminate this term and this term, and I'll find my b, right? If I put in x is equal to -1, that'll eliminate this term and this term, and I'll find my c. What term will I not be able to find doing it that way? A. So for this one, I'm going to go ahead and do the whole system thing, okay? So for the system thing is I'm going to just distribute these. Oops. You can, but let me just write the equation because I'm going to need the equations right now. So I'm going to have 4x squared plus 2x minus 1. Does everyone know where I got that?
Huh?
This guy right here. Okay. Is equal to distributing the ax. I'm going to have ax squared plus ax times 1, which is ax. Yes? Ax squared, ax. Then plus bx plus b plus cx squared. No, because the denominator is going to be down on both sides. So now I'm going to highlight because I love highlighting. Who doesn't highlight? I don't know anyone who doesn't highlight. Okay, so 4x squared, yes? Ax squared, cx squared. All have the x squared. So technically, I could write 4x squared is equal to ax squared plus cx squared, but the cx squared can be divided out. Does that make sense? So I'm just going to skip it and go to the coefficients and say 4 is equal to a plus c. Everyone good? Then I'm going to go in order. So here I have 2x, linear terms, yes. Ones with just an x. And so I'm going to have 2 is equal to a plus b. And then finally, I have this -1, and I just have this b, right? Those are numbers without an x.
Yeah.
So I have -1 is equal to b.
Wait, why wouldn't that? Remember the other problem that.
Well, the other problem I didn't have the term with x, so that's why it was 0. This one I have, like on this side, I have x squared. I have x, things with x squared, things with x's, and things without any variable at all. Over here, I have things squared, things with an x, things. So I have b is equal to -1. Everyone good?
Yeah.
I'm going to probably do back substitution here and do 2 is equal to a minus 1. Yes? So 3 is equal to a? I put -1 in for this b. And then up here I have an a and a c, but I know a is 3, yes? So I'm going to say 4 is equal to 3 plus c, so c is equal to 1. Then I go back and I plug it back in. So a was 3. So my final answer is going to be 3 over x minus b, which is 1. That's why that's a minus sign, over x squared. And then c is 1, so plus 1 over x plus 1.
That's our answer, we're done.
That's our answer, we're done. Well, you know what's sad for you is this one is, you're going to write somewhere. I don't care where. The nice one about this one is they're all distinct linear factors. So how are you factoring the denominator? You're going to start by factoring on x,
Isn't that one repeat though?
and you're going to have x times x squared minus 4. Can I factor it any further? X minus 2, x plus 2. You have 1, 2, 3 factors, which means you're going to have an A, B, and C term. None of them repeat, right? So this will be the denominator one place, this will be a denominator, and this will be a denominator. Everyone good?
Oh,
Well, you're going to pick A, B, and C. Yes. I'm going to pause the recording. I'm going to send you guys up to the board. Okay, I'll continue on with this. So you have this A plus B plus C. So this work is awesome, what you have so far. And then what I'm going to do is I'm going to highlight my linear terms, which are going to be, she did make it over. So when I look in here, when I multiply this bx times x, I get bx squared. When I take this bx times 2, I'm going to get 2bx. Cx times x, cx squared. Cx minus 2x will be minus 2cx. So now I'm going to look at my linear terms, which are going to be here. It's going to be 12, which I should have really written down here. And I'm going to have 2bx minus 2cx. So I'm going to write 12 is equal to 2b minus 2c. And then the last thing is I'm looking at my linear, so I'm going to have negative 4 is equal to positive 12. So if I do that, I'm going to have 12 is equal to negative 4a. So here I can solve and make a equal to negative 3. I'm going to put that a up here. So I'm going to have 1 is equal to negative 3 plus b plus c. So 4 is equal to b plus c. Then my other equation with b and c is here. And that 12 is equal to 2b minus 2c. I'm going to choose to do elimination. So I'm going to multiply the top equation by a negative, no, just 2, just plain 2. I'm going to have 8 is equal to 2b plus 2c. So I'm going to have 4b is equal to 20. So b is equal to 5. And then substituting it back into either one, let's go with the easy one. I'm going to say 4 is equal to b, which is 5, plus c. C is equal to negative 1. So right in the back where I have them, my a is negative 3, so I'm going to have negative 3 over x plus 5 over x minus 2 minus 1 over x plus 2. Now remember, if you change the orders of these two for some reason, and the x plus 2 had b, and the x minus 2 had c, then obviously these numbers down here in the change of work's going to look a little bit different. So that's your answer. Hope this helps. See you next time.